So, you watch Fight Club. Ooh. And you want to be Tyler Durden. But you're a biochemist, okay? I mean, it's not easy being Tyler Durden. You know, you still got like, I mean, you're brown, you live in a brown household. So what do? You start a soap business because that is the closest thing that's gonna make you into like Tyler Durden. So, what is soap? Soap is just like a hybrid, weird type of, right? So, remember, okay? Use your movie knowledge, okay? Remember, what did Tyler and the narrator do when they first met? You know, they were like, okay, so I make soaps. But Tyler was like, you know, if only these people, they knew the very, very fat, they like, you know, spend so much money to like get rid of. The very fat that they use to like get rid of their body is the same fat that they're lathering all over themselves to clean themselves. Like the duality of society, right? To use that knowledge, because guess what? It is true. Soap has fat, right? Let me explain it to you. So we've learned phospholipid, or I think I will try to cover it in this video. I'm not sure. Let's see. So this is my soap, bar soap. Very bad. This is soap. It's a really pretty circle though. So what does it have? It has two parts. Okay, one is hydrophilic. One is hydrophobic. Also, I'm thinking of getting a bigger board, like extending my board, because clearly this ain't enough. Hydrophilic means water loving, hydrophobic means water hating, right? So yeah, think of it like that. Hydrophobic is the fat part that he was stealing from those like liposuction factories. Remember, they crashed into a dumpster. Okay, hydrophobic. I don't know about you, but remember the house where they lived? Okay, there used to be like black water coming out. I don't know. Or it was like pretty rusty, like the tap was pretty rusty. So you can think of those like being rusty. So rusty probably means something with ions. Like at least I associate that like with ions. Ions. There was something like a use of hard water. So hard water means like, oh wait, no. I think I'm going in the wrong direction. Hold on. Okay, ions. Okay, so maybe you can think of sodium. Sodium is an ion. So sodium. So that is your hydrophilic part. So how do people make soap? How do people make soap? Now we know soap has two parts, right? Hydrophobic, hydrophilic. Now let's talk about the benefits first before like really talking about the reaction. Why do we use soap? I mean, out of everything, okay, we could possibly use, why a freaking soap? The answer is right there with you, okay? When we're like going from day to day, doing our shenanigans, whatever, okay? We are constantly interacting with particles that may be hydrophobic or hydrophilic. If there are any other classifications, I really don't have an idea at the moment. So, all right, I forgot to mention, this video is for self-revision purposes only. That means I will be watching these videos during the finals. So the examples used here are probably not scientific, just so you remember. I remember properly. Yeah, this video intends no hate towards any sort of discrimination, nothing, okay? I'm just fed up of actually reading books twice. So I read it once and then I make the whole video. Yeah, it's a video essay. So, what was I talking about? Yeah, so we interact with like a lot of things. That being said, like, you know, pollution, dirt, okay? I don't know about dirt, but it's like pretty, like it sticks to my face, right? And my face is pretty oily, so I'm guessing dirt is hydrophobic, like it's very oily type of stuff. But then again, there are other stuff. Okay, so probably like our skin is interacting with like a lot of hydrophilic stuff. So since soap can interact with both hydrophilic and hydrophobic stuff, hence that's why we use it as a cleanser. We use it to clean ourselves. It's just not a random thing that got rid of corona. It was very scientific. Okay, you can Tyler Durden your way out of corona, like a freaking pandemic. So what happens when a soap is on water? Okay, it forms foam. Okay, we know that. Wait, hold on. Let me show it to you. This is from one of my first videos. So, okay, I I can get rid of it. I feel like this is out of the frame. So we can get rid of it. But at the same time, like, what's with it? I don't understand. Okay, so how does it interact? You see that little hole. Okay, so I want you to just like see it right now. See, it's this thing that interacts with my hand and then it pops, right? But there's like a little hole in the middle, like which makes it the bubble, right? The little hollow. So that part is what I am guessing. So I'm not sure, okay? I'm guessing, I don't know if you can see it, is the hydrophobic part, the thing, the hollow. So that being said, let me just draw it for you. Enough bubble thing. I will probably end up doing it the whole day if possible. So this thing. Okay, imagine this thing being like, this thing just being like this. Right? Like the border is actually like this, right? So this black thing is probably the border altogether. So this thing is the hydrophilic part, I'm guessing. Hydrophilic head, hydrophobic tail. Okay, so since the hydrophilic tail forms the little border, the circumference of the bubble, right? And the hydrophobic part is what makes the hollow inside. Okay, so it looks so pretty, so magical, right? And when I touch the hydrophilic part, first because it's really like thin, that's why it breaks. It could also be because of the interaction of my skin, which is very hydrophobic with the hydrophilic part. I'm guessing, this is completely like in my imagination. That's why it breaks. Right? It makes sense. I feel like it makes sense. So this is how it interacts with water. Okay, so the foam, that's why when you make like a foam with, I should do it. I should do it. Like, what's stopping me? Just gonna use some of this soap water. I'm gonna use some of this soap water. And oh, I have a water gun. Am I cool or am I cool? And then, no, not enough. Not enough. But whatever. This thing, the foam, okay, it's not dissolving into my hand. Why? I mean, now you can't see it, but if I had like an actual foam right now, you'll be able to see it. You know what? We can recreate it with freaking hand cream. We can do it. So when you will hate the consistency of this. Okay, so this is now dissolving into my skin. I mean, it just did, but imagine this is soap. It will make like a foam. Why? Because it's the hydrophilic part is outside, okay, making the hydrophobic part inside. So the hydrophobic part doesn't really interact with my skin at first, okay? So this thing, it forms like a little cluster, okay? So I want you to imagine, wow, it's gonna be really hard to open these now. This thing is gonna be like this. Okay, so very bad diagram, people, very bad diagram. Imagine this. This is my bubble, right? So this little, you can see there's like a circle formed here, right? This part is what we call Michelle. I don't know if this is how you pronounce it, but that's how I call it. I call it Michelle. Okay? So this Michelle is because of the interaction of hydrophobic things. This is also no, let's not say that. This is not Michelin water, I'm guessing. But yeah. Okay. So this is the thing. You're getting how a soap freaking works. Now, do we want to talk about the chemistry inside it and actually become Tyler Durden? I really want to know though. You know, what was that little scene, you know, where the narrator put something on it and then, you know, you put vinegar just to like neutralize it. What was put onto his skin? If anyone knows it, ask you, of course. By that I mean you Google that and comment on your own videos, because self-sufficient much. So let's talk about the chemistry between like this whole thing. Now, if you remember correctly, which I'm guessing you don't, there's something like fat. Okay, hold on, I need a minute. Now, where I grew up, okay, I don't know about other places, where I grew up, glycerol was considered one of those like good moisturizer type of shit. I honestly don't know, I've never used it, but it was considered. Now, this is very important. You need to know. It's like a moisturizing thing. Okay. So now let's talk about fat. Okay. I literally forgot the structure for fat. But this is what the book says is the structure for fat. O, C, O, and then we got R. Yep. This is the structure for fat, as I can see from here. O, C, O, R. CH2OCOR. I guess it makes sense because, I mean, think of it. We got the ester here. So it could be triacylglycerol. Okay, so I'm not entirely sure of this, but this is some kind of fat. Okay, when we put this with sodium sulfate, sodium hydroxide, and water, we get glycerol and we get soap. Okay, so that being said, 3R, so imagine this. Oh wait, that looks weird. Okay, 3R, so let me just draw this whole thing first. O minus, Na plus, plus this. This is what soap looks like. Do we want to redraw this whole thing? Yes, yes we do. So I'm just gonna redraw this whole thing again. Now I sort of understood what's going on. So let me just, R. Okay, the R here. Then we have CO, O, oh, it was minus, right? O minus. Okay, so this part, it breaks. This part, it breaks. This, since there are 3 of those, we're gonna take 3. This is my soap. Okay, what's left? If you can see properly, then you're gonna see plus CH2. Oh, right, sorry. The Na from here is just gonna come to this side. It's gonna interact with this. So you can see the hydrophobic part, this, and the hydrophilic part. This, the sodium, right? Like this is an ionic interaction. So this, and we have CH2. Now we know that carbon, it's got 4 hands, right? 1, 2, 3. So H, H, H. We have 1 left. What's here? The sodium reacts with the soap. So what do we have here? The OH. The OH, okay? This reaction is not balanced, so I apologize for that. OH, OH, OH. Now if we want to draw the skeletal structure of this, so we know there are 3 carbons, 1, 2, 3. So we're just gonna connect those. For each of those, we have OH attached with it, like this. What does it look like? Glycerol. Glycerol. So this is glycerol. This whole process has a name. It's called saponification. It's the Leblanc way. Leblanc saponification. That's how you make soap. Now, thank you for watching till the end. Made a few mistakes. Not hopefully, but I hope you understood all the crap that I just explained. Let's talk about for your finals, dude. You really worked hard this semester. That being said, you did torture me a lot, but bye-bye. Another thing I forgot to mention, that's why I literally stopped editing, just to like show you this, okay? Leblanc saponification. This was what was initially used. Okay, so this was, I like to think of it as like before a time where pollution existed. So that being said, there weren't a lot of hard water, right? So imagine this. Okay, so this is before Tyler Durden, like, blasted all those finance broke places, right? So what happens is that when Tyler did all of that, right, after the blast, like, there was particles everywhere, so some contaminated the water supply. What happens when the water supply is contaminated? The water supply gets a lot of bad ions, so it becomes bad. I don't want to say it, I feel like you can feel the cancellation on my face. Although I don't think that was gonna be. I'm the one who watches my videos, dude. But anyway, hard water is created. So what happens is, this thing ends up reacting, or like this thing ends up reacting with other ions, and then the soap just ends up not working, right? It doesn't end up cleaning, rather making a scum. Like, like you would get like a little, like, water has like, you know, dirty water, it has like a little mark left over your sink or like your bathtub, if you're feeling unsafe. So yeah, so to avoid that, chemists came up with this new synthetic detergent. It doesn't say much about it here, so I'm just gonna draw the synthetic detergent thing in here. It's, first of all, you want to think a benzene ring. Okay, a benzene ring. Then here you want to draw S. You got one single bond O here. Can you see it? Yeah, you can see it. And then two double bond O here. And in here you got R. This is your synthetic detergent to get rid of the hard water problem. Understood, right? To get rid of the hard water problem, synthetic detergent was used, which I'm guessing, okay, the whole sulfur thing, it reacts with whatever hard water sent in there, and it just kind of like reacts with the ions there, making sure that the soap can just do its job. And also for lip balm saponification, I mean, think of this like that, okay? One way to remember, Fight Club was a 90s movie, right? It's like quite famous. What else is famous from the 90s? Friends. Actually, did you watch that episode of Friends? It's one of my favorites where Brad Pitt actually shows up, like, and they were like, we had a club. I hate Rachel Green kind of club. And you know, like a lot of people make edits of the club being, you know, Fight Club. So think of that like that. So Fight Club. So okay. So where else was like Tyler Durden in? Friends. Friends. Okay. So they had a club in Friends. Okay. Who else was in Friends? Joey. Who was Joey? Matt LeBlanc. And Joey also has this little thing, this little conversation with Chandler, where they have this conversation that Joey was like, no, Chandler was like, soap is soap. Soap is self-cleaning. And then Joey was like, really? Now, next time you use soap, think of the last place I put it and the first place, like the first place you're putting it in. And that stuff was wild, because I would say the same thing to my friends or like my parents and they would never believe me. But somehow when Joey says it, they believe it. Okay, duplicity much. So yeah, that's all for today. No, not for today. I think I'm gonna make another video for floss lipids, or I might not. But that's all for this video. Thank you so much. Bye bye.